Hello guys, today we will try to intuitively analyze various different kinds of RC circuits with current input. Most people will get confused when the input is current. So here the input is given as 1 ampere step current input. So if you see here, the input is changing from 0 to 1 at time t is equal to 0. We have to build a strong understanding how these RC circuits react with current source. This kind of analysis will be very useful in designing circuits for an analog VLSI engineer. So let's try to solve this. At t is equal to 0, what will happen to the circuit? At t is equal to 0, we know that capacitor has volt of 0 volt. Since they have given here, there is no initial condition mentioned, so we can assume VC of 0 is equal to 0 volts. So 0 volts can be approximated as short circuit, right? If something doesn't have voltage, means it's a short circuit. So at time t is equal to 0, capacitor will be short circuited. So your circuit will look something like this. Current source, resistor, and your capacitor is short circuited. Actually, indeed, here the capacitor is there, but we can assume it as short circuit. Okay. Now we are saying that 1 ampere current is flowing at time t is equal to 0 plus. This is the output node VO. The current will flow through this path. This is the R. So the voltage drop across VR or is equal to V out is equal to 1 into R. This is R volt. Okay. So VC will be equal to 0 volt. Why? Capacitor cannot change its voltage instantaneously. Now due to this 1 ampere current flowing, this 1 ampere current will flow in this path of capacitor. So if you take your capacitor like this current is coming as 1 ampere. So this current of 1 ampere will start depositing charges here. So it will start to develop voltage. The voltage equation can be given as VC is equal to 1 by C integral I dt, right? So it will be kind of dependent on time. I means 1 ampere into t. Okay, I into t divided by c. It is t by c. So it will keep on charging like this. Okay, let's see at time t is equal to infinite. At time t is equal to infinite, what will happen to the circuit? Is the capacitor will become open circuit? Most people will think that at time t is equal to 0, time t is equal to infinite, the capacitor should be open circuited, but that's a wrong way you are thinking, because here the current is continuously flowing. So there is no chance of when the capacitor will become open circuit if there is no current is flowing through it. Means when there is I flowing through the capacitor is equal to 0 ampere flowing into cap. When I flowing into cap is equal to 0 ampere, that time it will be open circuit. But here it is not that case, right? So this capacitor will keep on charging only. This 1 ampere will add to the capacitor and capacitor voltage will keep on increasing only. The slope is, what is the slope? 1 by C. Since this is T and this is VC, here the equation we have written, right? VC is equal to T by C. Slope is 1 by C. This is how the VC will appear. So what about this VR? VR will be constant across the time. Since I is constant, I here it is constant from this point to this point, it will be 1 ampere only. So it is keep on constant. So VR also will be of R volt. Okay. This will be constant, and when it comes to VC, this will be from 0, it will keep on increasing with a slope of 1 by C. Okay. Now what will be the V out? If you see here, V out is equal to, V out is the voltage across this and this. So it will be VR plus VC. Just add these two graphs, you will get V out is equal to, starting from this R point, it will keep on increasing. So it is R, and with a slope of 1 by C, it will keep on increasing. Okay, this is the V out equation. What about tau? Tau is equal to RC. Now, can we say this tau as this RC? If you say like that, it's wrong, because tau means when it will go and settle, but here it is not getting settled. So the tau will be, tau is equal to infinite. Very important thing. It will never get settled. Okay. In the next part, we will see what will happen if we add a resistor in parallel to the capacitor.